has to be lubricated so that small amount of oil lubricates the valve spindle and the guide. And also it keeps the guide cools, that is the cooling and lubrication, both is being done that way. And the exhaust gas should not leak upward direction because we don't want to go into the guide and the spindle, otherwise it will get seized. So that also it prevents. And also, of course, there is a air sealing air which is supplied also, that is that to prevent the exhaust gas moving upward direction. And exhaust air spring cylinder, if we look at this diagram. So in this, can you see my cursor on the screen? One of
Yes.
you can you see?
Yes,
Yeah.
Jeff.
Yes, we can
Okay.
see it.
So this is the air piston, and um, so this is the air piston. Underneath, the air compressed air is entering. Now what will happen? This oil which is supplied here, there will be some, this is the let us see first this diagram. This is the actuator. This is the actuator of this piston, which is in blue color, and hydraulic oil comes from top, and then this piston, and this is the air piston, and air spring air is supplied from here. Now there will be some leakage. Once this leakage, that while leakage and it comes to the downward direction, it comes on top of the air piston. Now when the air piston is moving down, when the valve is opening, then what happens? This air piston has a cylinder, this violet color. This cylinder surface, there will be oil, and this oil, some amount of oil will move downward direction, and it will be in the air spring chamber. And this slowly, this air spring chamber, then this oil will lubricate your spindle and the guide, as well as now this oil will get accumulated, keep on accumulated at the bottom, this space. Now, once this oil is accumulated at the bottom, this oil we need to remove also. Otherwise, what will happen? This oil will keep on, level will keep on increasing. So what it does, now this, another thing, let me explain. First, this air spring piston, when it is in closed position, we open first the air, then the oil, the pump. Now, this air pressure is 7 when it is in closed position when we started it. Now when it is opening, because of this pump and this actuator, when it is moving down, air will get compressed. That's and there is a non-return valve, air cannot escape through this. So this pressure will increase, and that pressure will be able to close the valve while closing. Because if you release this pressure, the pressure will be released from here, but it will not, it needs an upward force to close it. And that pressure closes it. It's around 30-35 bars once it is in compressed form. Now, once this, at the bottom of the air spring cylinder, the oil gets accumulated. What is happening? Your volume is reducing in the air spring chamber, isn't it? So once the volume is reducing, what will happen? Your pressure will keep on increasing, the air pressure, because this is liquid. Now, when you are opening the valve, that time the pressure will be higher. And there is a relief valve positioned here. And that relief valve as a setting. So it will be slightly higher than the, means it will be uh, as per the design, what is the pressure in the cylinder when the valve is open. It will be slightly, suppose it is opening, closing pressure, that is the, when it is open, the pressure in the chamber is around 35 for an example. So the relief valve setting will be around uh, 30, 34.8 or 35. So what will happen once the oil gets accumulated, and then the pressure will increase, relief valve will open, and this connection is at the bottom. So what will happen? Oil will come, not the air. So the pressure will be released by displacing the oil. So the, as it gets accumulated, it will come out and it will get drained into the system. It will get drained. So that is the way oil, and this oil will lubricate your spindle and the uh, guide, as well as this liner. This piston has got the Teflon rings, that, and the cylinder also will get lubricated. Uh, Now this valve, if you see this on top, there is a dumping pin. What is the purpose of this dumping pin? Dumping pin is uh, once this is put up the microphone. Once you are asking question, then only you put up. So uh, this dumping pin, what it does, when the valve is opening, we want to open quickly. But when if we want to close it same way, then what will happen? If it is quickly closing, there will be a hammering effect here in the valve and valve seat, and your valve and valve seat will get damaged, which you don't want. What we want, while closing, it should close slowly. So when it is opening, once the pressure in this piston is moving up, that much it has to displace from here. So the actuator piston will move down. This is the pump piston. Actuator piston, once it is moving down, it is opening. But when it is moving down, this dumping pin is fixed with the actuator casing. So only the piston is moving down. What is happening between the dumping pin and the piston? This space is increasing, and this space will be filled up by the your oil. Now, once it is moving upward direction for closing, then this space is occupied by the oil that has to come out, isn't it? So what will happen once, that will take some time. So the rate of closing movement of the valve spindle will reduce. So that's the way we can control the closing, so that it does not hammer the valve seat with the valves, so that it does not get damaged. That's the way we do. Now this piston, air piston, when it is moving down, this oil gets accumulated on the top of the piston, and part of it is coming downward direction in the cylinder. Now when it is moving up, not all the oil is going inside. So the, when it is moving up, then remaining oil gets come out from the site, and they, in this diagram it is not shown, another diagram it is shown, I'll show you. It is there in your handouts. So this comes out, overflows from here, and then comes out to the drain. There is a drain passage at the side, and these two drain actually it meets together and then goes out from the system. And this air to the valve guide, it is provided because of the lubrication, as well as it gives the sealing, so that the exhaust, when it is passing through this, it does not move upward direction. So we are actually losing some air. This air is coming out from here and it is moving out to the exhaust. So slide, it is a small quantity of air, but it prevents the exhaust to move upward direction so that this, the spindle and the guide, this clearance is maintained, which is not getting seized. And for this purpose, the valve rotor, what it does when the valve is open, this opening is, once it opens, it acts like a nozzle. So this is the high pressure, which is the cylinder inside, and this is the exhaust, which is going to the atmosphere. This is basically the atmospheric pressure. So once it opens, because of the nozzle effect, so there will be pressure energy will be converted into the kinetic energy, and with the kinetic energy, with the high velocity, exhaust will hit the valve. This is the wings, and it will hit the wings, and then it will rotate each time when the exhaust is passing through. And what is the reason for it? The reason for it is to turn the exhaust valve. Because if exhaust valve does not turn, what will happen? We have the fuel injector placed in the cylinder head, and there will be combustion. But in the combustion chamber, the temperature will not be uniform. There will be difference in temperature. That it means this valve will be exposed to different temperature. And there will be a certain location where there is high temperature, certain location there will be comparatively relative temperature I'm talking about. There will be slight lower temperature. So one portion, particular portion will be exposed to continuously high temperature, another portion will be continuous to slightly lower temperature. So there will be a deformation on the valve. Once there is deformation, what will happen? It means it is not expanding equally. So this will not seal your valve. It means valve will not be closed properly. So there will be a leakage. Once there is a leakage, and it will lead to finally the damage the valve. Valve will get burnt out. So to have the uniform temperature distribution so that the uniformly it is the temperature is maintained in the valve. So each time it rotates means different area of the valve spindle is exposed to that high temperature. So slowly, all the it will be evenly it will be distributed. And another advantage is when it is turning, so that it is having a grinding effect, so that no deposits can be made on the valve or valve seat. It does not allow any deposit on the valve and valve seat. Now, tell me, I'll go through the slides. Now, tell me any questions till now. Anybody has any questions, you can start, unmute your microphone and ask. Tell me. Valde, you have some question, correct?
Yes, sir.
Yeah, tell me.
Yeah, good morning, sir.
Good morning. Yeah, good morning to everybody. Yeah.
What is the purpose of oil which you are putting when we make overhaul? We will put some small oil inside the pistons. What this oil purpose?
Which piston you are talking about?
When we make overhaul exhaust valve, we will put small amount of lubricating oil inside.
So there are two pistons. One is the hydraulic piston, that is the operating piston. One is the air piston, spring piston. Which one you are talking about?
I think it's inside the hydraulic piston. I forget which piston, but when we make overhaul, before we assemble, we will put a small amount of oil inside.
See, this one, this part, what I am saying, air spring. Air spring also,
Yes.
you put a slight amount of this oil, because the oil from top, it will take some time to come here, isn't it? By the time
Yeah.
there will not be any lubrication. So we need to put some oil, and even at the bottom, certain amount of oil is maintained level. So our design is set so that the above that oil level, the space where you have, that pressure is enough to close the valve. And regarding this there is a vent. So once you start the pump, it will be automatically getting filled up because the air will get vented out. So modern ships, all the ships has got auto venting system. Have you done any venting or manually for the actuator, the hydraulic actuator? Because previously we used to do, but after that design is such, it is auto venting. Automatically the air will get vented. Once you connect the pipe, after overhauling, once you start the pump, it will get filled up with the oil. But here, this portion, you need certain amount of oil. And this portion basically does not need, but you can put certain amount, the space between the dumping pin and this hydraulic piston top. This space can be filled up with the oil so that there is no trap of air. Is it clear? Well day.
Yes, yes, sir. Thank you.
And any other questions?
Sir, this is Taka. I have
Yeah.
one question.
Tell me.
You said that when the valve spindle is moving up,
Yeah.
not to damage the valve seat, the valve spindle should have to be moved slowly,
Yeah.
slowly up. And it's not clear for me what the use of the damping pin. Can you repeat it again, please?
Yeah. So this dumping pin is attached to your, this is the actuator, this is the hydraulic piston, and this is the casing or the cylinder. So this is the dumping pin. Then the dumping pin is fixed on the casing. Now when it is opening, that time this piston will move down. Once the piston moves down, there is a space between the dumping pin and the piston, this space will increase. Once the dumping pin is in place, piston is moving down. So the space between the dumping pin and the piston, hydraulic piston, this space will increase. So once it is opening, this space will be filled up by this one. Okay. Once it is moving up, then what is happening? This piston will move up only when this oil has to displace. Is it clear, Rekha?
Yes, sir.
And to displace this, it will take some time. And that will cause the rate of closing less rate of closing. It means the movement upward direction is the closing direction. That movement it is restricting. You just think any hydraulic system, control system, you have a throttler, we throttle, isn't it? Why we throttle?
Yeah, but sir, the throttle have here in the drawing? No, I think.
No.
The vent is also serving as throttle? No.
No, venting is something else. Venting is like the virtual tappet. When it is expanding, it should come. When you start it, that time any air is inside the system that has to come out.
No.
Understood? Venting is stopped, for an example. This piston is moving up. That much oil, it will reduce the volume here. That much has to increase here. How will it increase? The hydraulic piston has to move down, and when it is moving down, this space is created. Oil will be filled with that. When it is moving up, this oil has to come out. Otherwise, it will not move up. It will not close, isn't it? So to coming out, it's working like a throttle. We do throttle in the hydraulics control system by, actually we are controlling the rate by throttling, isn't it? Here also it is same. So this is the spindle which has to move up. So it will move up at slower rate because of this effect. This oil has to escape from here. Escape where? In this chamber, not going to the vent. Understood? This has come from here only. So it will come back here. And that will cause the rate of closing at slower rate. Is it clear, Trika?
So, sir, when the spindle is moving down,
Yeah.
is there a free space on the top remain? Free space without having oil?
No, this space,
That means
as it is
vacuum
filled,
space.
complete space is filled with water. There is a clearance here, which is not shown
Yes.
here. So that clearance will make it's like a throttle. So once it is moving down, oil will come from here, it will come here in this space. And when it is moving up,
Yeah.
this will move.
Mm-hmm.
And this has to come out, then only it will move. So this will reduce the rate of closing.
Okay,
Rate
sir.
of movement
It's
of
now
the,
very clear.
yeah. Okay.
Okay.
So any other questions on this? So if no questions, then let us,
Yes, Chief.
yeah, tell me.
Chief, this is David. So in the air spring, you mean the what is remaining, the oil will be splashed and then it will get the valve spindle, or how it's working this oil?
No, say again, what did you say? Air spring?
I mean the oil which was collected on the bottom of this air spring piston. Yeah, there.
Yeah, air spring cylinder.
Later, yeah. So during closing or opening, when this air supply is given, it will be splashed. The oil will be splashed and lubricate the spindle, or what is the exact purpose of this oil?
That is the spindle and the guide. Because spindle is moving down. It is carrying, spindle is carrying that. Because in that, when it is moving up and down, the pressure variation will be there in the air spring. And this oil will be mixed with that air. And this surface of the spindle, surface which is above, inside the cylinder, air spring cylinder. So that will be, it will be on the surface of the spindle. When it is moving down, that oil will also move down with the spindle. And that will give a lubrication in the guide and the spindle. Clear? Understood?
Yes, Chief, it's clear. Thank you.
So any other question? If no question, then we go to the slides. It is the same thing what I said, but there will be some
Sir?
addition. Yeah, tell me.
Sophonius speaking.
Yeah.
So if we want to lubricate the spindle,
Yeah.
we have this air to valve guide, air to valve guide air.
Yes.
So wouldn't this air be sufficient to lubricate? Why we are supplying oil through the air supply? I mean, why don't we just supply dry air from air supply, but lubricated air from the air to valve guide? Because it's passing through the spindle and the slide.
This air is also can do the lubricate. It does the lubrication property, but it is poor lubrication property as well. We need the sealing also. This air, we actually don't want this air spring air to come down. Only the oil to come out. Oil will be adheres on the surface of the spindle. And that oil will come down. Not, we don't want air spring air to come down. And this air to guide is, it does the lubrication, but oil has got much higher lubrication property than the air. And it does the sealing. Otherwise, there will not be any sealing. The exhaust can move upward if only the oil comes inside. It is the whatever oil is sticking onto the surface of the valve spindle, that oil will come because it will adhere to the on the surface. Like the lubrication, you have already studied in details in bearing chapter. It is the same thing. Is it clear?
Okay.
So let's go through the you have the and there should not be a air lock. That's why you have the venting, so that it is a auto venting system. And you have the relief valve, which is dumping the top of the piston, so it reduces the hammering effect, because if you have the air in the system, there will be a hammering effect because it will move very fast. It will close very fast valve. If air in the system, it will close very fast. Why? Because air is compressive, so it will get compressed immediately. And you have already completed this. Why we have the wing, that is the rotator, so that it can rotate the spindle. So the purpose also we have already seen. And cage, that also we have covered, that it is cast iron, and guide also is cast iron, and seat is renewable. And we use the molybdenum still. Why we use the molybdenum? Because it has to be high temperature resistance, it has to be corrosion resistance, it has to be wear resistance. That is the reason this molybdenum steel is a very good property for working in that environment, because exhaust valve is exposed to your high temperature, corrosive environment, erosive environment, then mechanical stress, high mechanical stress. And also we use the stellite welding on the seat surface. It is so that it improves the heat resistance and corrosion resistance, wear resistance. It becomes. And this mnemonic alloy you do use, this is found to be very good and it is comparatively cheaper, but very good alloy we have. So this alloy you do use alloying material for the valve seat and valve. And valve actually it is in two parts. Valve is manufactured is a spindle. We don't need a higher grade of steel. We need the valve portion. So spindle and the valve, it is done by the friction welding. So what is actually friction welding? So uh, friction welding is, for an example, we have the valve. So this drawing might not be. So this is the spindle. So this is the valve which actually we need a higher grade of material. So what we do, we put it in the friction welding means this turns at very high speed, and this is fixed. Once this is fixed, because of the friction, there will be heat generated. So we keep both in closed position. So what we do, this is the spindle, and this is the valve, and this is rotating at very high speed, and this is fixed, and there will be a friction generated in this area, and because of the friction, this two part will get welded. That is called friction welding. If you see your ship's spindle, you'll see there is a color difference. This spindle color is same, this is same, but in between there is a slight burning color, the brownish color, slightly. It's very small, very light. And that area is actually the friction, it is welded by the friction. So we don't, otherwise it will be very expensive. So I have drawn it here, but it will be somewhere here. Is it clear, understood? How the friction welding is done? So this is on the lathe. It means it is a special lathe. It is holding this valve, and the spindle, it is on the vise. This is also on the vise, and it is holding, and then they bring together, and they make this two. And when it is rotating, what they do, they apply force from here. So it is under this direction force, and it generates heats and gets welded. Is it clear? Understood how it is built? Any question? And this is hydraulically, the pressure is applied. Hydraulic pressure. It is a special equipment and a special process to do this weld. And it is aligned exactly so that there is no mismatch. It is exact alignment is there, and then it gets welded. Clear? Any questions on this? Can you visualize on me? Anybody trying to say something? Or do we go back to the slide again, PPT again?
Sir, it's clear.
Yeah. So the friction welding is done. So the shaft is a steel shaft, whereas the valve head is pneumatic alloy. And seats should not be lapped.
If I have one question.
Yeah, tell me. Yo, tell me.
Yeah, I was trying to say something.
You are coming broken. Say again. You. I cannot hear you. Say again.
Sure.
Yeah, tell me.
I have one question.
Yeah, tell me. Tell me, you.
Why it is necessary to make welding? I mean, why it is not possible to have just one uniform?
One.
What is making? Yes, Chief. Can you hear?
Yeah. Okay. The purpose of making this way.
Necessary to make friction welding.
Yeah. Friction welding.
Why not we make from one material?
Yeah. So why we make?
Can you hear me?
Friction? Yeah, I can hear you. I am answering to that. So the welding.
Hello.
Yeah. Can you hear me? Tell me.
Can you hear me?
Yeah, I can hear you. I got your questions. Okay. So this is done because we want to make it cheaper, because this portion is exposed to the.
Can you hear me, Chief?
Yeah, I can hear you.
Yes.
I got your questions. I am answering to that. So now, this portion, which is the valve head, which is exposed to high temperature, high pressure, high corrosive environment, whereas the spindle part is not exposed to that. If you want to make a same mnemonic material, it will be very expensive. And whereas it is not required, because this portion is not exposed to those. So what we do, we make it in two parts. This is mnemonic, this side is stainless, steel. So then we do the friction welding to make it one piece. And friction welding, it is a very strong welding process. Is it clear why it is done this way? Yo. Hello. Is it clear, yo? Okay. So that is the reason it is done by the friction welding. And valve seat and the valve should not be lapped. Why it should not be lapped? Because they are not at same angle. And why the angle is different? Because angle is different because if we see the valve, so this portion, if you see this portion, so this material is much more than this material. So the expansion will be here more than this. So that is the reason the angle is kept in different. Yeah, you tell me. You're coming broken. Otherwise, what you do, you send me a text. Yeah.
And
Tell me. So you have sent a text, isn't it? Let me see. Okay. Okay, you. So now, if we see this area, the mass here is less than the mass here. So the expansion in this area will be more than this area. So that is the reason the angle is kept so that when it is exposed to operating condition, operating temperature, the expansion will be such so that the valve and valve seat, the face is parallel. It become parallel so that it can close completely. That's the reason when you dismantle and overall and assemble the exhaust valve, you'll see if you put a Persian glue and you check that how much is the contact area, it will make a circle. It will make only a circle. It will not be a complete area. So it will make a circle like this. On the, suppose you put the Persian glue on the wall and it will make an impression on the seat, it will make a circle. That is the reason, because it will meet at one point, because your wall will be like this is the wall seat and this is the valve seat and this is the valve. So it will make 1 point contact. So once it is expanded, that time this area at the edge, it will be more expansion. So it will become parallel and it will close completely. And that moment, the contact area will be the exact contact area. But in cold condition, it will make a circle. Is it clear what I said? So that is the reason it should not be grinded. If you grind it, what will happen? In cold condition, you will get the contact area high. But when it is in operation, the contact area will be reduced. It will change. And it will start leaking. Now,
So,
Chief,
sir,
can I ask?
yeah, tell me.
sir, this is Kaka. Can I
Yeah.
ask a question?
Yeah, tell me.
So, sir, you mean that it's not necessary to lap the valve spindle on the top of the valve seat?
No. For
I mean that
two-stroke engine,
I saw, yeah.
unless it is
Never.
told, it is given in manufacturer's manual, never do this. You will get the contact area. When you are lapping, what actually you are doing? You are increasing the contact area, isn't it? But
Yes.
when it is exposed to that temperature, it will be a different expansion, different situation. The contact area, instead of maintaining same contact area, it will reduce. So the sealing will not be proper. Unless it is given in the manual, you can do lapping, do not do. Because in that case, they have thermal expansion of the valve will be maintained that way. And most of the very few occasions it will be there. Because it will be very expensive valve then. Understood? The logic
Yeah,
behind it.
yeah, I understand the logic, but I have seen on the ship that they grind it first. They
Yeah.
grind it by the machine tool, and then after that they make it lapping in manual.
Manual lapping if
So
you do, but the grinding, was it at same angle or different angle? The moment it is different angle, do not do lapping. In that case, it will be same angle. This portion what I had shown, like here, this there is a, in cold condition there is an angle between the, this is the valve seat and the valve spindle.
Question.
Yeah, tell me.
Chief,
Yeah,
when we are grinding the spindle and the valve seats,
yeah.
we all usually measure both and we try to match. We don't do another angle adjustment usually on board the ship. Is there a limitation to that?
There is angle is already fixed. That particular grinding machine is for that vessel. So the angle, if you put your,
Usually there is.
it is fixed because your seat is putting in different direction. Once you put the tools, that angle will be maintained because that particular ship will have same valve, same angle cut. If both the angle is same, after grinding, if you put the Persian blue, what I told, you will see a different angle. It will make 1 point contact, like here, isn't it? So if the angle is same, then this angle is same means it will make complete contact. So that only that situation you can do the grinding. Otherwise, you should not do the grinding if the angle is different as per the design of the valve. It will depend on the design of the valves, and most of the cases it is different angle. So once you dismantle, you give a grind, you do the grinding of the seat and the valve. After that, you can check this by Persian blue, and you will come to know. If it is one, you get a circle, the angle is different. If you get the contact on the complete surface of the valve seat, it is same angle. And this angle is fixed in the instrument. That is the grinding tool you have on board the ships. That's why you see how you are giving the cut. Your valve you put upside down, isn't it? In operation, your valve is this. This is the position. But when you do the grinding, your valve is like this. Isn't it? And you do the grinding. The grinding tool is like this. But whereas seat, your tool is in different angle. here you are giving a cut or the grinding here. Whereas for the seat and valve, you are grinding here. So these two angle is usually it is different. Understood? This is the purpose of it. So many times,
Chief.
if there is
Chief.
a mistake, yeah, tell me.
So, yeah, this is the Chief. I heard some engineers, they don't like to make grinding on board because it's usually it's a little bit bad weather usually. So that's why they don't like to make grinding of this exhaust valve. It's not because of something else. I hear even the the seats, not only the valve, the spindle, also the seat, they make grinding together. It's only because of the bad weather, I heard. Is that something wrong or what?
No, no. Bad weather to avoid the vibration. So you can do it in port, the grinding. Or when the weather is good, you do the grinding. Understood? So there is no problem of doing the grinding on board. If you have expertise, skillful person, you will do it. Fitter is skillful, you will do it. Understood? Bad weather, this grinding is not done. It is always done in the good weather. Understood? So definitely you will not do in bad weather. Otherwise, due to the vibration, it will not be grinding, smooth grinding will not be. So let us proceed. So let's go to the slide. So now the valve rotation that we already covered it, that because of the overheating, we can prevent. Because what is the problem of this? Because your fuel injector is located at particular position. So close to that, there will be high temperature. So if rotate, it is not all around the fuel injector. You have 2 or 3 at a particular location. So that's the reason it has to rotate. And also it can impinge, because if there is a combustion, poor combustion, that is the penetration is high, flame can impinge on the valve, and valve, if it does not rotate the same pole location, it will get impingement every time the fuel is injected, that portion will get damaged. So if rotates, its new section of the valve disc will be subjected to that high heating as well as impingement. So there will be the temperature gradient will reduce. So the thermal stress will be reduced, as well as the damaging to the valve material also will reduce. So now one thing for the medium speed engine we do use for rotocap. What is the rotocap? Actually, rotocap for large engine we don't need to use, because we are using the hydraulic system. Hydraulic system once we use, then okay. Gratitude, tell me.
Yes, Sophonius speaking.
Yeah.
Chief, so due to these arrangements of the injectors,
Yeah.
we have different temperature stress on the valve. But what about the valve seat?
Valve
Wouldn't they be
seat,
affected by this?
see, valve seat will not be affected that much the way valve will be affected. Because if you see the area of the valve, which is exposed, and if you see the valve seat, which one is larger? Isn't it?
Yeah, the valve is larger.
Valve is larger. That is the reason. And valve seat, the thickness, it's almost, exposure is compared to valve is very, very less. That's why it is the valve rotates. Valve seat does not have to rotate. So
Okay, Chief.
yeah. So the roto cap is one thing which is mechanically it is turned the valve because valve has to rotate in medium speed engine. That is the reason one of the rotating method we use, that is the roto cap. So the purpose is same. So the spindle rotates, and for large means to medium speed engine also large engine we do use the spinner. What we have seen for the two-stroke engine, it is the same. Kinetic energy hits the vanes and it turns. But the roto cap, how it works actually. So, but there are some disadvantage of using roto cap. And when you are using the roto cap, you are using the spring. And this spring coil, the helical spring, which is used, and they are large engine. What we have, the spring has a frictional force which will prevent the valve to rotate. That's why we use the ball bearing on top. We do use so that the valve can rotate, whereas the spring will not rotate. It will be between the valve spring carrier and the valve cover, top cover, to provide that. And now the how does it actually occur? This the roto cap, but roto cap we do use for the four-stroke engine. And now one thing for the two-stroke engine, how we come to know that the valve is opening and closing as well as it is rotating. So there is a mechanism by which we can check this for other two-stroke engine. For an example, the BMW, how we do that. So if you see this diagram, the BMW, this is the lifting and rotation check rod. It means you can lock it, you can lift it up and lock it, turn it 90 degree. There is a slot on this and it gets locked. So that time we cannot, this will not give the indication of whether the valve is operating or the valve is turning or not. But what we do, we engage it, we lift it and we engage it, we can engage it. This one, this is a spring force which is trying to push this spindle downward direction, this check rod downward direction. And once we engage, the spring force will engage this this rod, check rod with the air piston top. And air piston top, once it is touch the air piston top, then what will happen? This spindle is moving up and down, as well as the air piston also with the spindle, it's moving up and down. So this will move up and down. So we know that yes, it is opening and closing because that is the indicator. But how will you come to know that whether it is turning or not from the outside? So there is a slot here. You see this check rod has moved, touched here, not on this surface. So this slot, once it is touching here, so now this distance from what we can see from top, this, for an example, this distance is reduced because it is touching here. Now, if this rod is touching here on this surface, so this will move up. So this piston top, if you see the air piston top, there is a slot like this. So the air piston, suppose you see from top, it is a circular cross section, and then you have one slot like this. So this slot, what we have seen, it is not all around. It is only on this. So the check rod will move down only in this. Now what will happen? This air piston is rotating with the valve. It is moving up and down as well as it's rotating with the valve spindle. This is the valve spindle at the center. So now once the air piston is turning, what will happen? This check rod is fixed at a point. So this check rod is not turning. It is only having the reciprocating motion. Now when it is turning, this check rod will come out from this slot at this point. Isn't it? Once it comes out, you will see it is moved up. So you need to check, you need to wait for some time to check that the full check rod is, if it is not moving, suppose, check rod will have the up and down movement because of the reciprocal, means opening and closing. But when it is coming to this point, that time check rod, in addition to that, there will be a movement. And that movement will ensure that the valve is rotating. Is it clear? Understood? This is the plan view of the air piston. From top air piston, if you see, there will be a slot. All the air piston, when you have overall, you have seen there will be a slot like this for the NW. And that slot purpose is, that gives an indication that confirms that the indicator will give an indication that it is rotating. As well as it is opening and closing, it will rotating also. Is it clear? Understood, all of you? What is the arrangement?
Sir,
Yeah.
sir, this is Taka.
Yeah.
I have one question. When this pointer moving up and down,
Yeah.
when the spindle is also, when the spindle is opening and closing, it's also going down and up,
Yeah.
up and down, yeah? So how can we distinguish
Yes.
that this movement is from the rotation or from the movement of the valve spindle up and down?
So for opening and closing, the distance will be much higher than this. Understood? So suppose the opening and closing distance is this. Whereas for this, it will be very less. So you can compare. Once you watch carefully, you will come to know. You will be able to distinguish, because the amount for the opening and closing movement, it will not be. You can see what you can do. You can do a mark. When it is open, it is at the bottom, lowest position, and on that here you can. Can you see the PPT now? Okay. So here, this check rod has got a tube through which it is reciprocating. And here at the lowest point, you can mark it. with the marker. Understood?
Okay, sir. Yeah, I understand.
So this is the purpose so that we know that it confirmed. But for the soldier, what they have a cyclus. So through the cyclus, you can see. And there is a marking. When it is rotating, you can make out because you can see the piston of the soldier. So that marking is rotating. So you come to know that it is rotating as well as the up and down movement is there. And for the intelligent engine, it is done by the sensor. So we have the sensor senses whether it is reciprocating or it is rotating, it can sense. So this is also already I have covered what I told you, that the hydraulic piston grips the air piston top that lubricates the air spring, and surplus oil will be collected, which is drained out, and oil which is entering into the air spring that accumulate in the bottom, and already I explained that how it gets drained out with the relief valve is provided at that line, and it becomes a mist. So that mist actually it lubricates the upper part of the valve spindle, and the lower part is done by the air, which is sealing air, as well as the cylinder lubrication. When it is done, that lube oil also it comes with the exhaust, and the lower part, which is exposed under the guide, that portion, that oil gets adhered to the surface of the spindle, and that also gives a lubrication. So the bottom of the valve spindle, that's when the bush is lubricated by the cylinder lubricator. That is the liner lubrication,
Chief.
because 100% it doesn't get burnt out. So there will be a carryover that gives a lubricating effect.
Chief,
Tell me.
I have a question, Chief.
Yeah.
So, Chief, that means the lubrication of the spindle will be taking place only during the closing of this stroke, the closing stroke of the spindle?
Yeah, closing and opening. If you see from top, when it is opening, that time, because both the situation, you need to have the lubrication whenever there is a relative motion. Whether it is closing or opening, both there is a relative motion between the guide and the spindle. So when it is moving down,
Yes, but the atomization will be taking place because of the air supply for closing of the valve. So it will be only splashed on the spindle during
see, there is no air supply. Air is supplied initially. Are you talking about the air spring air or the sealing air? Sealing air is continuous. Air spring air,
no
once it is filled,
air spring, yeah.
air spring once it is filled, that time air spring air, after that, do you need any air spring air to supply? Whether it is closing or opening? No, because that volume is occupied by the air. So when it is the opening and closing, there is a change of pressure, and that actually atomizes the oil, and it gets mixed up with the air. It is become a mixing of air and oil, and this air and this oil get adheres to the spindle, and when it is opening, it goes inside, but it remains on the surface, and when it is closing, that time also it does the lubrication. And the bottom part, it is the cylinder liner lubrication, that lube oil, whatever that is not burnt out, that comes with the exhaust, and it gives the It adheres to the surface of the spindle, and whenever there is a movement, whether it is down, when it is upward, it goes inside. But that remains inside. And then when it is downward, it does the lubrication same. Isn't it? Understood?
Yes, Chief. Yes, it's clear. Thank you.
So now another thing, if you see this diagram, so this is one of the simple sketch. Actually, for exam purpose, these sketches are very good, very simple sketch, and it explains everything. Have you seen this? It is in closed position of the wall. This air piston, it's slightly projected out from the line. This is the air piston, air cylinder line. This liner, this is so the oil gets accumulated on the top. When it is open, certain amount it goes inside for the lubrication. And then when it is moving up, it's closed position valve, this oil gets drained out from here. And there is a passage, you can see this through this passage, and then there is a drain. From there, it goes to the drain. And there is a this relief valve, there is a connection here. That this relief valve lifts, and this accumulated oil, it goes to the drain and then gets it drained out from the system. Is it clear, this diagram? And this sealing arrangement you have, this seal has got two seals. In between there is a telltale hole. If seal gets damaged, so saying that there will be a leakage. Suppose the oil is coming out, it means it is from the top, because oil gets accumulated here, or the air and oil is coming out. And from bottom also it can come, the sealing air from the gland, it can move up and it can come. So we know these seals are damaged. So accordingly, tell me, Sickness.
So, Chief, I don't understand the purpose of this air piston being projected out from this
Otherwise, what
liner.
will happen? There will be continuously this oil which is coming from the leakage, which is getting accumulated. Suppose it is moving down, that time this will get accumulated, and that is part of it will go to the cylinder. But once it is moves up, otherwise it will be filled with oil always, which we don't want. We want the quantity of oil to enter which is required for the lubrication. So the remaining oil will come out. Again, there will be a continuous leakage. So there will be another oil will come when it is moving down. There will be a lubrication, and it will excess oil, which is not entering, which we don't want to remain on top. It will come out from there. So the drain.
So we always have continuous leakage from the piston rings.
Certain amount, very little amount, there will be a leakage.
Okay.
So, any questions on this diagram?
This is a Taka.
Yeah, tell me.
So this the spindle seal. The spindle seal will not protect the oil not to pass to the down part for lubrication.
This whatever is adhered to that spindle seal will allow. Like if you think about the boundary lubrication, it is the first layer, which is because of the surface asperity. That will remain there, isn't it? So this is also reciprocating motion. So that much lube oil is good enough, because it's not always opening and it's not continuously reciprocating, and it is for the very little time. Any other questions on this? See this description. Hello.
Yes, Chief.
Yeah. So sorry for the interruption. There was an important call. That's the reason I had to attend that. No, let us start now. So this part everybody understood, isn't it? So now the
Chief, I have
yeah.
one question.
Yeah, tell me.
Malasa.
Yeah, tell me.
Chief, can you tell us something about this oil bleed valve?
Yeah. So this valve is
Thank you.
this is any now actually in modern engine what they do to ensure that there is no oil. So they bleed some, there is no air in the system. So part of it, they continuously bleed it. They remove part of it, it does not affect because they design such a way so it does not affect the system operation. And this, whatever is been removed to ensure that there is no air, because if there is air, there is a harmony, which is very adverse effect on the wall. So this continuously certain amount of oil will, but it is in controlled way, so that how much quantity it will be removed. And that will be compensated from the supply. You have the supply on the pump, that pump will have the, it will get compensated from here, because this is the supply with the non-return valve. Any loss of oil, that will get compensated by this, and continuously, intentionally, there will be a loss of. That is the oil bleed. And that ensures there is no air in the system, so there is no knocking effect on the valve and valves. Understood?
Yeah, understood, Chief. Thank you.
So now the cylinder head relief valve. So relief valve, it is spring loaded. It is a normal relief valve. Yeah. Tell me, definitely.
So this bleed valve is one which is adjusting the virtual tappet, or
No, what do you say?
there is something
Adjusting
else
the?
for the virtual tappet?
This bleed valve is continuously, but the virtual tappet bleed valve is removing certain oil, but it is not the purpose of virtual tappet. Suppose you don't have, you're talking about the bleed valve. Suppose bleed valve is not there. Okay, it is only air venting valve. So if there is a gas, which will come out, but still you need virtual tappet, isn't it? That is the relief valve. The purpose of bleed valve is to bleed certain amount of oil continuously. For your virtual tappet, you need one time only. Once it is at that temperature, after that there is no adjustment is required, isn't it? But bleed valve is continuously removing a small amount of oil from the top. which ensuring there is no air in the system.
Sir,
Yeah,
sir, this is Kaka.
yeah.
So this bleed valve is adjustable bleed valve, or I mean that is it different from the relief valve?
It is different from the relief valve. It is bleeding continuously. So
But I think relief valve is
pressure,
also
it is releasing
continuous.
pressure. No, relief valve is releasing the pressure, not continuous. Once it reaches to set pressure, it will relieve the pressure. That much amount, then again it will close. Bleed, the name itself you can make out, the bleeding means you are removing continuously something. So it's removes from the system, something you are removing from the system continuously. So in this case, it will be continuously to ensure there is no air in the system. And if you have a relief valve, it is the moment the pressure is increased because of the thermal expansion, it will get relieved. But this one, it is a throttler. So it will remove a certain portion of the oil. And it is as per the design. And it will keep on releasing, removing. Understood? Is it clear to you?
Sir, so this bleeding valve is, what is the purpose of the bleeding valve?
Bleeding
I mean
valve,
that if it is continuously bleeding, it will it has an effect on the oil pressure, yeah?
no. It means that much pressure is designed more. It will not affect your, because of losing this oil, it will not affect the operation of this exhaust valve. Exhaust valve needs certain pressure to open. That is the hydraulically it is opening, and this is extra to that amount. It will come out from the system. Suppose you design a hydraulic system considering certain leakage. Still your system will be operational 100%, isn't it? Yeah. And this is controlled way. It is not actually leakage by damage. So that much allowance you are giving. So it will not affect the operation of the system. So any other questions?
Chief Melissa,
Yeah.
for me it's not clear about virtue, because I was thinking that this valve, this adjustment valve, was using to adjust the virtual tappet. Can you tell us the difference between this valve, or is there some another arrangement for the virtual tappet?
Yeah, it is the relief valve. It has. See, this development took place later on. There was no, before when we used to, we started using the hydraulically operated valve. That time this was not there. So there was a vent. So this vent is to remove the air from that vent. And even during the operation also you could vent. On the top there is to be a ball valve. So you could push with the screwdriver down that, and once the oil is coming out, you just stop it. So this virtual tappet, it means when there is an expansion of the valve spindle, that much volume has to come out. Because of that, there will be a change or reduce in volume on the top of the hydraulic piston. That much oil has to come out. That is the virtual tappet. Now, if you have some passage which is continuously removing and you don't have control, you have, as per the design, there is a fixed amount of oil will come out. You cannot control. Means after that you cannot control. Now suppose due to the expansion, will there be same expansion? Might not be. There will be different expansion in different load condition of the engine. So if you have a system which is moving the oil continuously at a constant volume, will it help the expansion, thermal expansion of the valve spindle? It will not be,
No.
because you don't have control over that. But whereas you have a relief valve. So your relief valve is maintaining a certain pressure. Now because of this change of volume, reduction in volume, what had happened? Pressure has increased. And it is releasing that pressure by what means you are releasing the pressure? The same volume it is taken out from the system. So the tappet is adjusted. Understood?
Okay. Yeah, understood. Thank you.
Yeah. Safnias.
Jeff?
Yeah.
Yes, Jeff. So this relief valve, is it
Yeah.
located on the valve itself on
It is
cylinder
there.
head or somewhere else on the
It
pipe?
is there on the pump.
On the pump. Ah, okay.
Yeah. Because
Thank
it is
you.
the same system, so no problem.
Yeah, okay, thank you.
So now the cylinder relief valves. Cylinder relief valve is spring loaded. Why you need cylinder relief valve? So that it releases the excess gas pressure, so that because all the material which we do use, it has got a certain design pressure which can withstand. It means it has to be maintained. Operating pressure should be below that. And then you have a relief valve which actually excess pressure, if there is any circumstances, there is excess pressure that has to be released, so that the material does not get, the component does not get damaged. So in relief valve setting should be definitely below the design pressure and above the operating pressure. So usually it is 20% above the engine design pressure. Here it is written design pressure, but it is designed operating engine pressure. So it is maintained that way. Now I ask you one question. Is there anyone of you have not seen the relief valve on the cylinder head? Anybody have not seen the relief valve on the cylinder head? So I consider all of you have seen the cylinder head relief valve, but there are design you might not have. Yeah.
Chief,
Yeah.
sometimes this is Orkana.
Yeah.
So sometimes this one is coming with indicator cookies.
Indicator cock is
I'm not
coming
mistaken.
because there is some reason. I'm not talking about that. You actually interpreted this way, that is it installed on the cylinder head or not. But it comes with
Together, I mean, together with.
Together it comes because number of hole we make on the cylinder head, it become more number, more we are weakening the cylinder head material more. That is the reason we use a single passage for indicator cock and the relief valve. It's correct. There is a relief valve which is on the, instead of having on this directly mounted on the cylinder head, it is with the indicator cock to avoid the number of hole, to reduce the number of hole, so that the cylinder head does not get weakened. That is the reason. But sometime what that the studs which is securing the cylinder head, they are elastic studs. So if there is a pressure, excess pressure, the head lifts and the pressure gets released. But there is a gasket in between, but gasket does not get, in that design, gasket does not get damaged. Otherwise, if your cylinder head lifted, if this is not the design, then many cases gasket get damaged, that software gaskets. But there are some engine, they have this arrangement also. But most of the engine you have the relief. And it this sets pressure is around 20% on the maximum operating pressure. And it is the spring loaded. So it is spring loaded. This is the valve, and this is the this lifts with the pressure. This is subjected to the cylinder pressure, and this is the spring force, which is, we can adjust the pressure, set pressure by the adjusting screw on top, and then accordingly we can, once this pressure which is subjected to the cylinder pressure, it lifts it more than the spring force, it lifts and then it comes out from the side. And there are drill holes. So here also what will happen if there is any leakage, once it is lifted, this pressure can go to the upward direction. We don't want any pressure to accumulate on top. It has to come out from the side. Otherwise, what will happen? The set pressure will increase. There will be cylinder pressure on top as well as the spring force. So it will open at higher pressure. So which we don't want. So this is the way it works, and this is the lock nut spring retainer, because this is the spring which is in contact with this component, and this is the spindle, and then this is the valve housing and the stop rings, so that this is how much means this is a stop ring which is for the valve to lift, how much it will lift, this much it will lift, because beyond that it will not lift, because this is attached to your in-between sandwich between the casing and the valve. This is the valve guide, this is gasket, because cylinder head, you are connecting to the cylinder head, there has to be a gasket so that it does not come out. You will get released from the side, and this is the valve flap, and this is the spindle is coming here. So, is it clear, the construction part? Any question from the construction part?
Sir, this is Taka. I have one question here.
Tell me.
When this release valve is opening, the pressure will drop under the designed pressure of the cylinder head, or it's just open and closing? It's working like open and closing.
It is open and closing. But only thing it will have a higher lift, because once it is upward direction force is acting on this area, once it is lifting, it will lift this area also will be subjected to the pressure, so it will lift and then it will close at the same pressure. So it will maintain the pressure. Its purpose is to protect the excess pressure to release, to protect the cylinder.
Okay.
So let us see this description. Now the valve seat has to be examined. What we do, we check the surface visually, and if required, we do the lapping. That is the ground. And spring also to be checked. We check the free length. What is free length? When a spring is not subjected to any force, that is the free length. So that free length is important to us, because once it is in use, it is a compression spring. So what will happen? The free length might reduce. Once the free length is reduced, means your spring force will be changed. That's why the free length is important to measure. What is the warping? Warping is one factor actually. At one time it was not given so much important, but it is very, very important for spring. So warping is something, the cross-sectional area deformation. So suppose this is the cross-sectional area, so it gets deformed. It can be deformed in different ways. So it can be deformed like this, it can be deformed like this. So this deformation affects the spring action. That is called warping. That is only the cross-sectional area, which is important. So you must check the cross-sectional area. It is uniform or not. It is a circular only. So when do you inspect it? So that is to be checked, and then after assembling, you must do the bench test. What is the set pressure and it is according to the design of the engine, it is opening at that pressure or not. Now you can check that. You can check that with the hydraulic pump with making adapter with the pressure gauge connected, so that you know that you can find out. Just one sec.
ጋይስ አንዳንዴ በኮኔክሽን ምክንያት ስንወጣ ተመልሼ መግባት እየከበደኝ ነው እና ምን ማድረግ እንዳለብኝ ተባበሩ።
So okay, let me start, because there was another call which is important. Now you know that there is COVID-19. There is some issues come. That's why. So I had to attend. It is official. So let us. Is it clear the working effect of the spring? That has to be checked always. It has to be checked, and after assembling, you need to do the pressure test. And pressure test testing tool, actually you can, if it is provided by the makers. If not, it can be made on board also. So you need only the one adapter, and you have the pump always available on the ship. So you can hydraulic pump is used because it is at higher pressure. That is after that you can install it. It ensures that the it is working at correct pressure. Opening pressure is correct, and this the lifting pressure is important, because it is cylinder pressure is released, and also when it is released, be careful, you should not be close to that, but you can make out which one is lifted. And it should not leak, then the power, the cylinder pressure will be released, or it should not also released at higher pressure, neither lower pressure, both will have adverse effect. And also this once it is lifted, there is chances of flame. Why it is lifted? Because of the high pressure. Why it is high pressure? Because of the combustion. The temperature is high. So in that case, it can be hydraulic also, but most of the cases it will be the combustion gases at high pressure. And when it is expelling from the cylinder, the flame will come out and the seat can get damaged. That is the one thing. It means once it is lifted, there are chances of seat getting damaged. And sometime you'll see during the maneuvering and the slow running, it happens. Why it is happening? Because when you do the priming, that time maybe there is some leakage and oil gets accumulated on the top of the piston. And once you start the engine, there will be a violent fire, and that can cause the lifting of relief valve. But after that, you will see there is no lifting. Then it becomes normal, because that had happened because of initially accumulated oil on the top of the piston. So this also it can happen, because if there is any leakage in the injector is faulty, then also it can happen. And pump setting is high. What do you mean by pump setting is high? Pump setting, the quantity of the fuel, it is too high, then also it can happen, because the more oil will enter and there will be a violent fire. And then incorrectly timing also can affect this, because once your timing is like in advanced, too much advanced, then that will cause very high pressure, and that also can lift your relief valve. That's why there is a limit how much you can advance the timing, fuel pump timing. So you should not go more than that. And also when it happens, when the air brake we use to stop the engine. This in details I'll go in another chapter, it is there, the crash stop. But in brief, you'll understand what is it. So we suppose we are running the engine in ahead direction, full ahead to full astern, suppose we are given. And in that case, what will happen? Your telegraph area moved to the astern direction. The moment telegraph you move to the astern direction, it will change your reversing, starting and reversing mechanism to reversing system. That means your distributor will be reversed, your fuel pump will be reversed, but will it stop immediately? It will not stop the engine immediately. The engine is still running on ahead direction. And because of that, in this situation, it is the wrong direction, isn't it? Because it is running in ahead direction, but you have changed to astern direction, the control. But air will be injected. Our engine is direct air injection system, that is the starting system will be used. So air will be injected, but fuel will not be injected. So the fuel will not be wrong way, fuel will not be injected, but the air will be injected. But the air, when it is injecting, actually it will not, air will not be injected in the right angle because it is rotating in opposite direction. So in that case, the air will enter, but air, instead of turning the engine in the right direction, astern direction, what it will do, it will break, it will have a braking effect of the engine. So it will break the engine to stop. Because your engine has to stop, then only engine will turn in opposite direction. So that in that situation, the air which is injected into the cylinder will do the brake effect of the engine, so engine will stop, and then it will convert into it will change to the reverse direction. Now when this braking effect happens, that time the pressure increases very high. Braking effect is happening when during the compression stroke. Compression stroke, it is the air is injected instead of expansion stroke because of this opposite direction rotation. So the pressure in the compression stroke will become very high, and it will affect the engine pressure. Means engine pressure will be more than the relief valve pressure it can be, and the relief valve will lift and release the pressure. It happens during the crash stop. It is normal. There is no problem. And then the safety valve will lift momentarily, release the pressure, and then it will sit back again. And valve lifts during the running. This is what is the indication? Indication is the overloading. And what is the problem in this? It means the timing fault. If it is, then the camshaft drive, it means it is a problem with the camshaft. So we need to check the timing, fuel pump timing, that has to be checked. So it is only designed for hello. It is only, yeah, any questions?
Yes, I have a question.
Yeah, tell me.
So during crash stopping, if air is removed by the relief valve, what is the use of crash stop? How it will stop if it is released instead of
See, it will crash stop. Your relief valve setting is for the combustion pressure that is higher than the compression pressure, peak pressure, isn't it? But
yes.
It means your compression pressure, even if reaches to the peak pressure, it will not lift after that 20%. But It can happen in the compression stroke. It will increase more than that because of that breaking. And that pressure, once it is increased, it will affect your design pressure. So before that, it should get released. That is the reason. Because if your compression pressure is very high, compression is before PDC, so it will try to stop the engine. Understood?
Yes, so that means it's only this extra pressure because after the compression pressure and before the setting of the relief valve, that is the one which will make the crash stop.
Yeah, because the excess pressure only it will remove and relief valve will leak, but it will not affect the crash stop. For crash stop, below that pressure is enough to have crash stop. Understood? Yes. This will be taught to you in details. I'll teach you in details in another chapter. It is there, crash stop. So the safety valve, it is designed such a way so that excess gas pressure is released, so that it does not damage the engine component. And even it can happen due to the, as I told you, that it can be because of the hydraulic pressure, that cooling water is leaked onto the cylinder. It can happen because of that also. In that case, also relief valve will lift and it will come out. But this, it is actually designed for releasing the excess gas pressure, not the hydraulic oil. That's why we do the blow through, so that there is no accumulation of the liquid on top of the cylinder. It can be fuel oil, it can be water. So before starting, that's the reason we do the indicator cocks to keep it open, and slow turning we do to expel these leakages, because your relief valve is designed for excess gas pressure. Otherwise, your cylinder will get damaged, component will get damaged. Now, the cylinder cover, it is universally accepted. All the modern engine, we have the cylinder cover, and there is a central board in which the exhaust valve is installed, and at the side we have the EU. Tell Emmanuel to join the meeting with that password and ID. He is trying to contact me because in Zoom the problem is you can have only one session. You cannot have parallel talk. So ask him to join the meeting with a lecture with the password and ID. So this is all the engine we do use this type of cylinder head, so that we can have the central passage is for the cylinder in the exhaust valve, and it is board cooling we do use, because board cooling is found to be very effective. That's the reason even for the cylinder head we do use board cooling. And the cylinder head is secured with the studs of the cylinder block, and these two studs is for the port stud for securing the cylinder exhaust valve. So board cooling is principle we do use. We know that board cooling in the liner we have already completed that portion. So the thermal stress we can reduce, as well as the mechanical stress, and the cylinder head. Cylinder head also is subjected to very high thermal stress and the mechanical stress. And cylinder head, if you see at the bottom, the construction is a curvature so that we can have so cylinder head have the curvature like this, so that and piston crown has curvature like this. So it forms a shape which can withstand very high pressure. It's not a flat face. So we make it this way. So we can reduce the thermal stress in the this. And what is the material we do use? It is the forged by the forging we do, and the bore cooling. There are passages. It is kept, and now these struts, which is securing the cylinder head to the cylinder block, that is elastic struts, and exhaust valve is we use the mnemonic 80A. This is found to be very, very effective in that condition, working condition, at high pressure, high temperature, high corrosive atmosphere, high erosive atmosphere. So we do use this for the exhaust valve, and it is bolted in the valve cage. So the injector, 2 to 3 injector we do use. Why we use more than one injector? Because one injector, that is the base location we are not using for the fuel injector, that is at the center. Centrally located on the cylinder head because of the exhaust valve. So we need to compromise with that. So we need to put it at the side. And once we put it at the side, if you put one, it will not be, the oil will not be distributed evenly on the cylinder, inside the cylinder, that is the combustion chamber. That is the reason you need to at least have more than one, that is 2. And usually 2 to 3 we do use. And to have the symmetrical distribution of the fuel. And sometime what we have, you'll see in the cylinder head, around the fuel injector, that area, there is a cladding, there is a plate which is different material than the other part of the cylinder head. That is the inside, means the in way of combustion chamber. So that plate is, it is actually intentionally is done, that is a cladding, and this cladding is done because of the anti-corrosion, so that this property of that material is high, upper grade than the other material, because that area is subjected to the very high corrosions. So that is the reason that cladding plate is used in that area. It is intentionally is done, it is not that it is a repair. So that it can protect the cylinder head. So it can prevent from the corrosive hot gases as well as erosive heat, because there will be particle in the combustion gases as well as fuel. So it should not get erosion, should not happen on the cylinder head. That is the inner surface I am talking about in way of the combustion chamber. So, four-stroke engine, as we know, we use the rocker arm to open and close the valve. So this is the rocker arm. So this is the push rod, and this is the rocker arm, and this is the valve. So here in this diagram, we have the 2 sets of valves, two valve exhaust valve and 2 valves inlet valve. So there are advantages of using the more than one valves. Usually we use 2 valves. So there are some disadvantage of using only one valve. We could have used only one valve, isn't it? But we don't use, usually we do use 2 valves to have certain advantages. We'll see that it is there in your syllabus. So the tappet why do you have the tappet? It is because of the thermal expansion. So during the working condition, temperature increases. So there will be valve steam, there will be an expansion, and because of that, we need to keep a tappet clearance. And tappet clearance, it means once the engine is in operating condition at that temperature, that clearance becomes zero. So that it is designed such a way so that the makers gives you the values, how much it should keep, and you keep accordingly, so that in cold condition, and it should be taken in cold condition. You see in the manual, it will be written whether that clearance is given to you at cold condition or hot condition. It will be given to in cold condition. So you should measure that in cold condition. If you measure it at hot condition, but whereas the value given to you is in cold condition, then what will happen? Tell me what will be the effect if maker says that 0.5 tappet clearance in cold condition, but someone by mistake he has checked that in hot condition. So what will be the impact? Tell me. Yeah, Safnes, tell me.
So if we are given with cold condition, 5 millimeter, and then we measure it in hot conditions, this means the valve stem already is expanded. So when we make the measurement, it will be less. So we will adjust it to a much higher value than the 5 millimeter. So when it is in cold condition, it will become maybe 5 point something or 6.
Yeah, so 0.5 I said, so it is an example. So yeah, because 5 millimeter will not be there. It will be in that range it is usually. So 0.5, 0.4. So yeah, you are right actually. If it is hot condition, somebody has measured it, then what will be the effect? Effect will be the tappet clearance is less tappet clearance. What are the impact of that? It will have. So this tappet clearance is important because the valve operation will depend on that, because the closing and opening, whether it will completely close or whether it will be completely open, and how much it will be opening, all this will affect on this. And once it is not closed properly, there will be leakage. Once there is a leakage, it will valve and valves will get burnt out because it will become weaker. And also there will be hammering effect if there is a clearance is more, because clearance is more means once in operating condition there still clearance will exist, so it will hit every time it try to open the valve. As well as what will happen if it is clearance is more, will there be any impact on cam? Who will answer? What will be the impact on the cam, or will there be any impact on the cam if the clearance is more? Anybody would like to answer my question? Yeah, what name? Admasu, tell me.
Sorry, Chief, what's the question?
Question is, suppose there is excessive clearance of tappet. Will there be any effect on cam? Because Rockadam is operated by the cam.
Yes, I think there will be an effect on the cam.
What will be the effect?
There will be a hammering effect on the push rod. So this push rod hammering effect will impact also the cam lobe, the cams.
So yeah, it is similar to that. What will happen? There will be shock loading. What is shock loading? Suddenly load will increase and suddenly load will reduce. Because the moment there is a clearance, load is zero, isn't it? The moment it is opening, load will be very high when it is touching the spindle. So then there will be a shock loading. There are four-stroke engine with hydraulic tappets. It's not exactly the two-stroke engine what we have seen, but it is there in your syllabus in another chapter. I'll go in details. But how, if you have, for an example, something like this. So you have a roller and guide, and suppose this is the roller and guide, and you have a push through guide. And in between this space, you have hydraulic oil. Understood? And you have the rocker-arm, you have the top part is same. You have the rocker-arm, so this is the same. So you have hydraulic oil here, and this hydraulic oil push rod upward direction so that there is no tappet clearance depending on any load. This is the spindle. Because of this hydraulic pressure, there will not be any clearance at any load, and it can be adjusted from here depending on the load. So there are two-stroke engine, they do, and four-stroke engine, they do this type of arrangement also, so that the tappet clearance can be adjusted hydraulically. This it will be in details in another chapter. Okay, understood. In brief, this is the arrangement. If you have a hydraulic, it is not directly connected. This push rod and the follower, guide and follower. In between, you have hydraulic oil. So hydraulic oil, suppose this expansion is high, it will move up. So what will happen? This distance between these two, this will reduce. So this will occupy the space by the hydraulic oil accordingly. Understood? The basic concept is this. Is it clear?
Yes, sir. Sir, I have one question.
Yeah.
On the shocking on the camshaft.
Yeah.
I mean that even we adjust the clearance. If we adjust correctly, the tappet clearance, there is loading time, and there is also no load time. Yeah.
Yeah.
Even the tappet clearance is adjusted correctly. So how can we say that if we adjust it excessively high, the shock will be more on the camshaft?
Yeah. So this there will be a clearance here, isn't it?
Yes.
If it is excessive. Now what will happen when your push rod is moving up? Certain time it will be zero load.
Yes.
For certain time. But if there is no clearance, immediately load will come. And then what will happen? After that, this load will increase. When it is releasing the load, suddenly it will become zero for certain time. Understood? That will affect the cam. The shock loading will increase. Whereas there will be variation. What you are talking about, the loading on the cam, that is correct. But it will not be this way. The shock loading will not be this way. Here the shock loading will be, because certain time there will be zero load. Whereas in that case, from minimum load to the maximum load, the time, and it will be smooth. It will not be like loading is 0. Then it is increasing. Whereas in that case, the loading will be, and it will happen both cases. Either it is closing or opening. So this from here to here, this will be a problem. Because of that, shock loading will increase. Understood, Tekan?
Yes, sir. It's clear. Thank you.
So that is the reason self-adjusting hydraulic tap four-stroke engine also do use. Some engine they do use. And excessive clearance, the problem is like valve will not, means if the clearance is less, insufficient clearance, then what will happen? The valve will not be closing fully. And once it is not closing, there will be leakage. Once leakage will start of exhaust during the power stroke, during the combustion, all the gases, the flames will pass through that. And first what will do? It will weaken the material of the valve. And once it is weakened, the strength of the material will reduce and it will get burnt out. So it will get damaged. And once it is, first it will make a groove. After that, it will see it is become larger and larger. That's why if you have experienced of burning, damaging the valve seat of the exhaust valve, you have seen the exhaust temperature slightly increased. You may, because of emergency, you do what you do, emergency use, you do control the exhaust temperature, because then we look at the exhaust temperature. How do we control? We reduce the fuel quantity. And quantity, how do you reduce? You reduce the fuel rate. But the temperature reduces. You see, after some time again increase. Because once it is leaking, it will get damaged. You cannot save the valve. So that is the temporary measures we do take for emergency purpose, so that the ship reaches to the safe place to change the valve. And if it is insufficient clearance, this will happen and it will get burnt out finally. It will get damaged. So now tell me, till now, any questions? Anybody? Yeah, what may? Tell me. Yeah, what name? Speak. What may you?
Yeah, Chief.
Unmute. Yeah.
Chief, if somebody, for example, adjusts the clearance wrong and, for example, very less clearance, is there a possibility that the piston will touch the valve? And if you touch, which part of the will be damaged first? I mean, the stem, the piston, or the push rod?
So it will get damaged both. But this thing, a push rod will get bent. But if you see the clearance, how much clearance you do take? 0.5, 0.4, around that range, isn't it? So it means you have adjusted the clearance. But what do you mean? Is it when the valve is open, even suppose somebody has made mistake, usually the chances of piston getting touched by the valve is very, very rare. Because when do you take the tappet? Tappet when both the valves are closed position. And it is in that condition, even piston can be at TDC, isn't it? And that time you are checking the tappet. It means if it is suppose in an adverse condition it happens, the push rod will get bent, as well as it will damage your piston rod, piston crown, as well as the exhaust valve or the inlet valve. But push rod chances of getting push rod bend is very very high chances. But if you think about the clearance, if it is only the clearance, but it is procedure of the position of the crank angle was correct when the valve was in closed position, then instead of 0.5 maybe 0.6 or it will be actually less in that case. You will not be adjusting more than that. But in any case, if it happens, then push rod will have bent, as well as the piston crown and piston valves also will get damaged. Yeah. Any other questions till now? Anybody? So once the chapter will be completed, I'll give you more assignments, and but the next chapter will continue. So you'll have to keep on preparing the assignment of previous chapter. Is it? I mean that we'll do now. That is the way. First, we'll complete the chapters and assignment, but you prepare the assignment. Next chapter, once the chapter is completed, next chapter will start. And you have Saturday, Sunday, 2 days off, so you can prepare it.
Hello, sir.
Yeah, tell me.
This is Joseph. Sir, can you give us some time? We have some issue to discuss each other. So can you, we stay online with this channel and we have some issue to discuss. So can you give some 10 to 15 minutes to discuss?
Yeah, no problem. 10, 15 minutes. You have some questions. And another thing, the 1900 to 2100, it is a repeat class. So anybody can join. It's not that whoever missed this lecture will not be able to join that. Understood? Now, Eob, another thing. Eob, you take the attendance and you'll give me on each lecture, you'll take the attendance. How many of you from your laptop you can see? Note down.
Yeah.
Send it to me. Okay. End of the day, you give me all 3 lectures. Plus, whatever is the lecture a day, you give me.
Okay, so I will.
Only you can do one thing. Only you give me the absentees, because the present will be more in number. Okay.
Yes, Chief. I will do that.
Yeah. Advasu, yeah.
Yes, Chief.
Tell me.
Chief, if it is possible, when you give us the password, can you please make them with the letters which are different, small letter and capital letter, because we are confusing with, for example, small letter and capital letter, if they are the same. We are confusing. I mean, if they are similar. So
is it same you are getting? When I am sending you, no, you just copy and paste.
Yes, I just copy and paste, and I was entering without any problem.
But I have written what is the exact password. The first time there was a W was capital, but it was small letter, then it was corrected.
Yes.
Yes, Chief, but we were confused with O and 0. That was
Okay,
the
yeah,
problem to join.
yeah. So if you see O is like a circle, and if it is 0, if you see, it is like elliptical. It is expanded vertically. Can you make out? If you
Yeah,
look at,
okay.
yeah.
Okay, Chief, I understand.
So now, any questions? Those actually could not discuss during the lecture. Any question? They want to do some. They want to ask something. So ask. Yeah, all day. Tell me. Unmute your microphone. Whoever is speaking.
After finish the class, is
Yeah.
it possible to have the slides?
Which slide you are talking about?
The lecture which you are giving to us.
Are you
possible,
talking about the PPTs?
No, the PowerPoint, which is now we are learning, yeah?
Yeah, this PowerPoint is exactly the same PowerPoint which I use in the class, and it is exactly the same way as your handouts.
All right.
It is the same. Soft copy of the handouts all of you have gotten. And hard copy definitely was given, but later on soft copy also is given. It is
Yeah, we
exactly
are.
the same. There is no difference.
All right, sir. Thank you.
Any
Chief, this is Malasa.
tell Melissa, tell.
Chief, is it possible to send us this handouts, the hard copy which was in the campus to Addis Ababa, because it was not possible at that time to bring.
Yeah. Is Mr.
Yes, Chief.
Rishabh contacted you?
No, he didn't contact me yet. I was waiting his call.
Okay. So do you have his number?
Yes, I have.
So you contact, because already I informed, and you contact Mr. Rishabh, and it will be arranged if possible. Definitely it will be arranged. And as I told you,
Okay.
as I informed you, accordingly you speak to. You tell him that I have told
Okay.
you to contact.
Okay.
Okay, thank you, Chief.
Yeah, you will. And
Sir,
yeah, tell me.
Sir, can we record the lecture from it? Because when I am asking that to record, it's asking a permission, I think, from you.
Yeah.
And if possible, you can record it and you can send us by email also. When we need to repeat it, we can see it also.
It will be allowed for you to record. So there is no problem. And those you could not record means once you can record, then there will not be any distribution because you will be able to record. And those you have not recorded, that will be, I'll send it to you. No problem. Because this
Okay,
lecture
you,
you could not. And last lecture, if any lecture you cannot, you inform me, I'll send the recording because instructors are recorded.
Okay.
okay, sir. Thank you.
Yeah, tell me who wants to speak?
Yes, Chief.
Yeah.
Sophonius speaking.
Yeah, tell me.
So can we try this
Chief,
recording now,
Chief.
just to be sure?
Yeah, this is Emmanuel.
Yeah, Emmanuel Safnas was on the line. You want to say or let him finish? Which one you want?
Okay, so Phineas, he will finish and after I will speak, no problem.
Safnas, complete.
So can we try this recording so that we will not be disturbed in the next class?
Yeah. So Okay, this I'll check and I'll give you the access for the recording. Okay, and I'll tell other instructor also and guide them so that you will be able to next class onward you will be able to do that. Okay.
Okay, Chief. Thank you.
Yeah. Now, Emmanuel, tell me.
Okay, Chief. What I'd like to say is previous classes as well as this one because I miss and I cannot get it at this time. Also this one because I joined on the half because at the beginning class, that's why.
So what is the question?
In what way you will send out this recorded copy of the lecture?
It will be, see, it will depend on the file size. I will send. If it is large file, I'll send. There is a way it can be sent. Which one do you have? Do you want to say something of transmission?
No, I'm not saying about anything to say actually, but just I need the recorded copy.
Yeah, it will be distributed.
I mean,
yeah, Emmanuel, it will be given, so that you can go through it. Now, you, if I give it to you, can you distribute to everybody? You.
Yes, Chief. Yes, it's possible. I can distribute.
Okay.
Otherwise, even yeah, I can.
Like the handouts you did, no?
Yes, yes.
Yeah, so I'll send it to you and you will distribute to everybody. Now tell me, those have joined late today, what is the reason?
Oh.
So any other questions? Actually, one of you requested that to extend the class for 15 minutes around so that he has some questions. We missed some portion, that's the reason. Any questions?
No, sir, I think we don't have any more question about the subject. We have some other idea to discuss. We should have to discuss today. That's why just leave us for 10-15 minutes and we will discuss with our language and we should have to decide some things. That's why.
Okay. So